Hello students, today we are going to talk about heat capacities from calorimetry. Before going ahead with the topic, if you want to improve and excel in maths and science, then do check out the micro courses offered by Infinity Learn and don't forget to use the coupon code HQ10 for additional 10% discount. More details are given in description. Now let us get back to the topic. Let us first talk about thermal capacity or heat capacity. Now we might have experienced that different materials they require different amount of heat to get heated up. We might have also observed that some type of food they cook very quickly and some food take a longer time. That means they required more amount of heat for getting cooked. And based on this we have this property which is defined and it is called as heat capacity. So heat capacity of the body is nothing but the amount of heat required to raise the temperature of the body by 1 degree Celsius or 1 Kelvin, and it is denoted by capital C prime, and it considers two things. Pehla, so what is the amount of heat that is consumed, and second, what is the change in temperature. So if by providing amount of heat equal to Q, if the change in temperature is delta T, then the ratio of this is nothing but heat capacity. Now you might think about what will be the SI unit. So heat ka SI unit we already know is joule, and temperature ka unit is degree Celsius, or we can also use Kelvin. Similarly, for heat, we can also use calories as a unit. So the probable units are joule per degree Celsius or joule per Kelvin or calorie per Kelvin or calorie per degree Celsius. So finally, once again, let us sum up what is heat capacity. So if you take a particular body, no matter what is the mass of the body and dimension of the body, what is observed is how much heat is required to raise its temperature by 1 degree Celsius, and that becomes its heat capacity. Let us also talk about the other units of heat capacity, which is calorie per degree Celsius or calorie per Kelvin. We can also use kilocalorie in case the amount of heat is higher. So it is kilocalorie per degree Celsius or kilocalorie per Kelvin. So if I have 1 kilocalorie per degree Celsius of heat, it will be nothing but 1000 calorie per degree Celsius. So this is the relation between calorie and kilocalorie. 1 kilocalorie is nothing but 1000 calorie. Also, let us talk about what is the relation between calorie per degree Celsius or per Kelvin and joule per Kelvin. 1 calorie is near about 4.2 joules. So 1 calorie per Kelvin becomes 4.2 joules per Kelvin. Now let us talk about specific heat capacity. As we already said, heat capacity does not account for the mass of the body. It takes body as a whole. Now in heat capacity, if I start expressing heat capacity per unit mass, then that particular property is called as specific heat capacity. Let us check the definition over here. Specific heat capacity of a substance is nothing but the amount of heat energy required to raise the temperature. The additional thing over here is of unit mass of that substance by 1 degree Celsius or 1 degree Kelvin. Now this thing is denoted by small c, and small c over here is nothing but the amount of heat required per unit mass per unit change in temperature. So that change in temperature can be denoted by delta T. So this is nothing but specific heat capacity. Once again, for units, amount of heat has unit joules or calories, and mass will have unit gram or kg, and finally temperature will have change in temperature, or temperature will have unit Kelvin or degree Celsius. So we have multiple units over here possible. First one will be joule per kg per Kelvin, or you can write it as joule per gram per Kelvin, or it can also be written in terms of joule per kg per degree Celsius or joule per gram per degree Celsius. Let us take example of a material. Copper has specific heat capacity equal to 0.4 joule per gram per Kelvin. What this means is कि every gram of copper will require 0.4 joule of heat so that the temperature is raised by 1 degree Celsius or 1 Kelvin. I hope this part is clear to everyone. Now from the formula that we have over here, if we rearrange this, we will get Q, the amount of heat absorbed, is equal to M into C into delta T. Now this particular equation tells us that the amount of heat absorbed to increase the temperature is dependent upon mass, and it is directly proportional to mass. It is also directly proportional to specific heat capacity of the body, and finally it is also proportional to the increase in temperature. Also, out of all these units that we have seen over here, let us quickly try to relate a couple of them. So if I have 1 calorie per gram per degree Celsius of heat, this will be equivalent to 1 kilocalorie of heat per kg. So 1 gram had required 1 calorie for 1 degree Celsius rise. Now I need 1 kilocalorie to increase the temperature by 1 degree Celsius for 1 kg of the same substance. Also, we can convert this into joules. So as we know, 1 calorie is nothing but 4.2 joules. So this will be equal to 4.2 joules, but we have kilocalorie over here. For kilo, we will add 10 raised to 3. So 1 kilocalorie will be 4.2 into 10 raised to 3 joules per kg per degree Celsius. So I hope the relation between the units is clear to everyone. Now let us also discuss about specific heat capacity of some common substances. We have denoted the specific heat capacities in 2 units. One is joule per kg per Kelvin, and the other one is calorie per gram per degree centigrade. So first we have lead and mercury. They have specific heat capacity around 130 and 140, and as we go down, what we find is specific heat capacity is increasing, and we find that for kerosene and ice, the heat capacity, specific heat capacity, increases to 2100. And finally for water and seawater, it is almost 4200. From this we understand that water has the highest specific heat capacity among the common substances, and it requires 4180 joule, around 4200 joules, to increase the temperature by 1 Kelvin for 1 kg of water. Next, let us talk about the relation between heat capacity and specific heat capacity. So specific heat capacity, we already said, it is nothing but the amount of heat absorbed or released per unit mass per unit change in temperature. And we already saw that amount of heat absorbed or released per unit change in temperature is nothing but specific heat capacity. So what we have is C dash, which is nothing but heat capacity. It is equal to mass of the object into the specific heat capacity of the object. So what we have over here is heat capacity of a body, which is denoted by capital C prime, is equal to specific heat capacity of the body times the mass of the body. Let us quickly check out the differences between heat capacity and specific heat capacity. So first of all, heat capacity is nothing but the amount of heat energy required to raise the temperature of entire body by 1 degree Celsius या 1 Kelvin. And specific heat capacity के लिए it is the amount of heat energy required to raise the temperature of unit mass per kg या per gram of the body by 1 degree Celsius or 1 Kelvin. Second, heat capacity depends on the mass of the body. Higher the mass, more is the heat required, and it also depends on the nature of the substance of the body. Specific heat capacity does not depend on the mass, it is the property of the substance. So its value will vary from substance to substance. So you will have different specific heat capacity for copper, for steel, for iron, for metal, for other metals, for non-metals, for water, and everything else. Let us check out their formulas. So specific heat capacity is nothing but the amount of heat absorbed per unit change in temperature. And for specific heat capacity, we have amount of heat absorbed per unit mass per unit change in temperature. SI unit becomes joule per Kelvin or joule per degree Celsius. You can also have calorie per Kelvin or calorie per degree Celsius. For specific heat capacity, we have joule per kg per Kelvin or joule per kg per degree Celsius. Kg can also be in grams and heat can also be expressed instead of joule in calories. So I hope we have a clear understanding of heat capacity and specific heat capacity. Thank you very much.